Hi, our topic is the transport equation. And what is the transport equation? The transport equation describes how a scalar quantity is transported in a space. Like this one is the scalar quantity, and usually it is applied to the transport of the scalar field, like the chemical concentration, like always inside a incompressible flow. Like this is flow, and it will movement by this flow in by the mathematic point of views. The transport equation can divide it by two movement. Like the first one is the convection, and the second one is the diffusion. And these two combined is the transport equation. Like this convection is just movement by time and some displacement, and the diffusion is the scalar quantity moved by the flow, and the concentration will be changed, like it will diffuse by this around. And this transport equation we always can use in the chemical concentration. Like I can show you guys some pictures. Yeah, you guys can look this one. This one is the smoke propagation inside the garage due to the internal ventilation systems. This color change is the smoke concentration change. And the next one, it can show the population in the atmosphere. Like this is the some smoke. Like the color is the concentration change by the movement by the atmosphere flow, like that.
Now let's look at the equation. ut plus cux equals 0. The constant c here may be physical units or have some kind of significance in the problems that the transport equation is modeling. Let's imagine that we have a wave. You can think of a water wave, a density of something in a fluid, moving along with a constant speed c. This is how this wave is moving by time. To see this, we can draw it in a coordinate involving all the variables we have here, x, t, u. We can draw this wave at different time slices. At this time, it is like this. At this time, it moves a little further. At this time, it moves a little further, and so on. Notice that u is a constant along certain lines in xt plane. As the shape of the wave is not changing, we can get the equation for these lines, which is x minus ct equal to x now, where x now is a constant. Since u is a constant along these lines, the directional derivative of u equal to 0 in the direction of x minus ct equal x now. Thus, we can get a formula like this, which is cux plus ut equal to 0. That is exactly the transport equation. To solve the transport equation, we need to have an initial function ux0 equal to fx at time 0, which is a continuous and differential function that indicates the density of the moving object. The general solution to the transport equation would be uxt equal to fx minus ct.